Propionic acidemia is a rare metabolic disorder that prevents your body from processing proteins and fats through the propionic acid pathway. The signs and symptoms of this enzyme deficiency can sometimes be hard to differentiate from other metabolic disorders. In this video, I'll give you a quick visual mnemonic to help you recognize these signs and symptoms and to confidently answer questions about propionic acidemia on test day. Let's start by looking at that giant vat of acid. You know, the kind of acid vat that movie villains use. This one even has a propeller inside to keep the contents moving. It seems there is a ship stuck inside, and the good guy is trying to break it out of the acid before it gets dissolved. We'll get back to this ship later. For now, focus on the propeller. This propeller in acid should help anchor you to this scene on propionic acidemia. Get it? Propeller for propionic and acid for acidemia. Propionic acidemia is named aptly for the buildup of propionic acid seen in patients with the disease. Now let's talk about why this happens in the first place. Take a look at the good guy trying to break his beloved ship out of the acid vat. He happens to be holding a croquet stick as his weapon. Wait a minute, croquet? Isn't that Pixarize's recurring symbol for CoA? Or coenzyme A? It's the CoA croquet stick. Notice how he is also standing on a cardboard box to reach the propeller vat, which also happens to be Pixarize's symbol for carboxylase enzymes. You know, it's a cardboard boxylase enzyme. And the hero is swinging at the propeller with his croquet stick on a cardboard box, which together represents propionyl-CoA carboxylase enzyme. Looks like he's even making some progress in breaking the vat. This breaking should help remind you that we are talking about a broken or defective propionyl-CoA carboxylase enzyme. If you've seen our video on the propionic acid pathway, you would remember that propionyl-CoA carboxylase is the enzyme that catalyzes the conversion of propionyl-CoA into methylmalonyl-CoA. For more details about how this enzyme works, you should review our dedicated video on the propionic acid pathway. So what does a defect in propionyl-CoA carboxylase cause? Well, let's look back at the propeller in the vat. This propeller and the name of the disease, propionic acidemia, implies an increase in some propionic compound, right? Well, since we can no longer convert propionyl-CoA to methylmalonyl-CoA, propionyl-CoA naturally builds up. Since propionyl-CoA can be freely interconverted into propionic acid, this naturally increases the levels of propionic acid. So blood tests of patients will reveal elevated levels of propionic acid and propionyl-CoA, since they are kind of the same thing. And there's another lab finding that is highly relevant in these patients. Take a look at our pilot's ship. Wait, isn't that the Malonial Falcon? Yep, this metallic Malonial Falcon ship is our recurring symbol for methylmalonic acid. You know, metal for methyl and malonial for malonyl. Remember that propionyl-CoA is usually broken down to form methylmalonyl-CoA by propionyl-CoA carboxylase. Since this enzyme is deficient, it should follow that patients will have decreased methylmalonic acid levels. Methylmalonic acid, or MMA, is a blood test regularly used to measure vitamin deficiencies, but decreased levels of MMA can be a clue for propionic acidemia. Next, let's talk about some demographic features of propionic acidemia. Notice how our hero happens to be standing atop a small cart as well? This small cart is our recurring symbol for the autosomal recessive inheritance of propionic acidemia. Since a cart is just a type of auto, and this cart is definitely small, or recessive, right? Autosomal recessive inheritance is a pretty low-yield inheritance pattern, as it doesn't encode any gender preference and simply tells you the disease is pretty rare. It's far more important to remember the other clinical features of the disease. One thing that we didn't symbolize here is that propionic acidemia usually is seen in babies and young children. This should make sense, since the disease impacts one of the major pathways used to metabolize amino acids. In other words, this disease impairs a patient's ability to break down proteins. Not only is breaking down proteins pretty important, but it's also worth noting that the buildup of stuff like propionic acid is toxic. Therefore, this disease is pretty severe, making it present early in life, aka in babies. I didn't symbolize this because you should have the intuitive understanding that most diseases of metabolism happen early in life. Make sense? Now let's talk about how these babies will present clinically. Seems there was a fierce fight here earlier between our hero and some of the villain's guards. Take a look at that knocked out guard lying on the ground there. Yep, he looks pretty flaccid. This flaccid, passed out appearance should remind us of the hypotonia seen in patients with propionic acidemia. In babies, this presents as flopping baby syndrome and failure to meet motor development milestones. Next, if we look to the other side of the acid vat, we can see a lever which must control the propeller for the vat. By the way, doesn't that handle look kind of like a liver? It's the liver lever. This liver is here to remind you of the hepatomegaly observed in propionic acidemia. I like to think of this as the toxic propionic compounds building up inside the liver. Our hero is really going at it to save his ship. He's hitting the vat so hard that the vat is shaking. By the way, the shaking is here to remind you of seizures, another key finding in propionic acidemia. The cause of seizures is pretty complicated, but you can think of this as being caused in part by neuronal damage as a result of propionic acid buildup and methylmalonic acid deficiency. Before we close, I want to take a second to mention that there are no curative treatments for propionic acidemia. We can't really restore the defective enzyme. Instead, treatment is mostly supportive, involving stopping seizures when they happen, liver transplants if necessary, and following a diet low in protein, since protein contains the amino acids that cause the toxic buildup. For more details on the specific amino acids involved, watch our video on the propionic acid pathway. Alright, it seems that our hero is about to finish rescuing his ship, so let's quickly summarize. Propionic acidemia is an autosomal recessive metabolic disorder caused by the deficiency of the enzyme propionyl-CoA carboxylase. This leads to decreased levels of methylmalonic acid and a toxic buildup of propionic acid, measurable in the blood of affected patients. Typically, this disease presents in infants or young children with hypotonia, hepatomegaly, and seizures. Now, when you see lab values with low methylmalonic acid in a child with hypotonia, hepatomegaly, and seizures on test day, you won't have any problems diagnosing propionic acidemia. Until next time.